device overview. They are again giving some elaborating to some extent. The document contain device specific information about following devices. These are the devices. Among these, we are going to work on this one. PIC 16F873A, 876A devices are available only in 26-pin package, while PIC 16F874A, 877A devices are available in 40-pin package, 40-pin and 44-pin package. All devices in PIC 16F87XA family share common architecture. Their instructions are same. Their method in which their function registers are operating, that is same. The way in which we read the data from memory, that is same. What site of memory that they are using to store the program, that is same. But there are certain different. What are those? Those are listed here. PIC 16F873A and PIC 16F874A has 1/2 of the total on-chip memory of the PIC 16F876A, PIC 16F877A. If they have 8K means they may have only 4K memory. 1/2. Right, total chip memory of this. That is what right now. 1/2 means that is what meaning, right? So then 28-pin devices have 3 I/O ports, while the 40 and 44-pin devices have 5. 28-pin devices have 14 interrupts, while the 40 or 44-pin devices have 15. You can ask me a question here. See, you told only one interrupt vector. One interrupt vector means if there is an interrupt, whether it is a external hardware interrupt or serial port interrupt, timer interrupt, for every interrupt, program counter will be loaded with memory location 004. Program memory location 4. How they can handle 15 different interrupts? See, 15 different interrupt in a single memory location. How can they handle? For this, every interrupt that they are saying here, all those 15 interrupts that they told, no. If any one of the while the 44 plus 5, they have 14 interrupts, while some 15 interrupts right now. If any one among the 15 interrupt happens, they will make a flag bit to set. There will be a function registers. In those function registers, they have 1 bit allocated for one interrupt. Let us say timer interrupt. If there is a timer overflow, they will go and set that bit to 1. Okay. If it is a serial port interrupt, they will go and set the serial port interrupt bit to 1. But whether it is a timer interrupt or a serial port interrupt, the program counter is loaded with 4, program memory location 4. Let us say the interrupt happened is a timer interrupt. Program counter is having at the memory location 04. Now we have to execute only timer interrupt service routine. But among these 50 interrupts, any one happens, the program counter will come to 004. Now the question is how the microcontroller knows that it should execute timer interrupt service routine. Each interrupt has their own interrupt service routine, no? How does the microcontroller know that it should execute a timer interrupt service routine? Any idea? How to handle this situation?
Can you repeat the question, sir?
Okay, let me explain it pictorially. so that you will get what I mean. This 40 or 44 pin microcontroller has 15 interrupts that they are seeing right now.
Yes, sir.
Give me a sec. I think it is. Why it takes this much time? This is my main program, right? In my main program, I do some operations, some initialization of port or other things. After that, I wait in a while, infinite while loop. The program counter is simply waiting here. It simply execute no operations and waiting here. At that time, I have started the timer here. Maybe you can say start timer and then initialize serial port. Like that, I have done many things here. When I am waiting in infinite loop, current memory location address is memory location, program memory location in which we have while loop is, let's say it is 3010. So the program counter is simply waiting in 3010 and executing no operation. As I initialize the timer here and initialize the serial port here, after some 1 second, my timer is over. Timer expired. Program counter value is currently PC. Program counter value is 3010. When the timer is expired, program counter, it will generate a timer interrupt. Come on. Wow, what happens? Okay, it becomes 18. Am I doing anything wrong? Come on. Timer interrupt. It is not typing. Maybe it is typing. It is too small. Wow. What is this? Okay. Thank you. So timer interrupt generated. When the timer interrupt is generated, will be immediately program counter will load the address 0x 004. This is a program memory location. So it comes here. When the program counter is in program memory address format, it won't simply stand there. It will try to fetch, is there any instruction in the memory location 4? It will take it and will execute it. So timer is expired, it will come here. If serial port, if I type some character from the keyboard so that it receives the serial port interrupt, even in that time also the program counter will be loaded with 004 only. Now my question is, when the program counter is at the memory location 004, how does it know it should do the work for timer interrupt or it should do work for serial port interrupt? There should be some distinction, no? When for this interrupt as well as this interrupt, it comes to this particular memory location. But after coming in 004, whether it should it execute a timer interrupt or service routine or serial port interrupt service routine? How does the microcontroller will create a distinction between these two?
There will be priorities also.
Come on.
Priorities will be there.
No, not priorities. When they come here, actually in this 004, they will have a branch to main ISR. This main ISR may be written at the memory location 0x5000. There, moment the program counter is loaded with 004, either for a timer interrupt or for serial port interrupt, they will branch to main ISR, main interrupt service routine. In this main interrupt service routine, they will check, validate different flag bits. I told no. If it is a timer expired, timer interrupt, they will set the timer interrupt flag. If it is a serial interrupt, serial port interrupt, they will set the serial port interrupt flag. In this main ISR, they will check whether timer interrupt flag set. They may use a switch statement. If it is timer interrupt flag is set, means timer interrupt happened. So they will have a child ISR. This is main ISR. Then the child ISR is like a timer child ISR, interrupt service routine. So in the main ISR, they will decide which service routine they have to execute based on the inspection of flag bits. For every interrupts, there is a flag bit. All these 15 interrupts that they are talking here, no? Every one of them will have a flag bit. After they come to this main ISR, they will inspect those flags. Right. If a particular flag is set, they will go and execute that interrupt service routine. If, for example, a timer interrupt is set, they will go and execute. Now the question, another question. Okay, among these 15 interrupts, all can happen at different time? No, there are possibility to occur two interrupts at the same time. Your timer may expire. At that point, you may also receive a character. Both can happen at the same time. That the coincidence can happen, no? Now, what should microcontroller execute? Whether it should execute a timer interrupt or serial port interrupt, because both are happen at the same time. Both flag will be set to 1. At this point only, whatever Amir told no, priority will be there in the interrupt. So which one is having higher priority, that will be executed. The lower priority one will be ignored. Do you understand how this interrupt service routine works now? For whatever that they told, these 15 interrupts will be implemented in the software. Come on.
Yes, sir.